Now, the conclusion is that when you interpolate the signal in time domain, that means in time domain when the signal gets expanded by the insertion of 0 samples, in the frequency domain you can see the frequency spectrum gets compressed. And when the compression takes place, there will be extra space to accommodate the repeated versions of x of omega. So these repeated versions of x of omega will now fall in the range minus pi to plus pi. As a result, we will have to carry out some kind of filtering now, because we don't want these repetitions to be available. Ideally, there should be only this original spectrum which gets compressed and available from minus pi by I to plus pi by I. The repetition that we have are called images of original spectrum. So these are called images of the original spectrum. So we will require a filter after the process of interpolation, which will have its passband from minus pi by I to plus pi by I, and it will remove all these images or the repetitions which have on both the sides of the original spectrum. So in concept, now the process of interpolation will never occur alone. We will have process of interpolation taking place. Up arrow means upsampling, and capital I will be the factor of interpolation. But after the process of interpolation, we must have a filter, and this filter is called anti-imaging filter. Anti-imaging filter because it helps to remove the images those are generated as a process of interpolation. So the input to this interpolation block is, let's say, x of n. The output of interpolation will only be called w of n. Only after it passes through anti-imaging filter, the final output will be called y of n. So how do you write this whole thing? W of n is equal to nothing but x of n by I, which is the result of interpolation. Y of n will be equal to w of n convolved with h of n. What is this h of n? H of n is nothing but impulse response of anti-imaging filter. So input convolved with impulse response gives us output y of n. As per the definition of convolution, this is summation w of k into h of n minus k, where k will vary from minus infinity to plus infinity, and therefore my y of n will hence become summation w of k will be nothing but x of k by I, because w of n is x of n by I, so it is x of k by I, and k will vary from minus infinity to infinity, and this will be multiplied by h of n minus k. I can now do a small simplification. I'm going to say that let k equal to, let k by I, so I'll replace k by I with another variable m. If I do that, then k will be replaced with m into I, and this will give me y of n equal to summation x of k by I has become x of m into h of n remains as it is, k is equal to mi, and now the new variable instead of k, the new summation variable will be of m, and m will vary from minus infinity to plus infinity. And finally, if I want, I can go back to the original variable k, because m is nothing but a dummy variable inside the summation. So if I go back to variable in the form of k, I can write it as x of k into h of n minus ki. Instead of m, I will now write k equal to minus infinity to plus infinity. So this is what we get. This is the final expression of y of n, which will be output of anti-imaging filter. So please remember that. To summarize the whole thing, interpolation process will always be followed by the anti-imaging filtering process. So final output y will only be taken from the filter. So now if you remember, decimation requires a filter before the decimation process. We call it anti-aliasing filter, and interpolation process requires filter after the process of interpolation, and this is called anti-imaging filter.